example 5, which is at the bottom of page 3, we have 11 different scenarios that we are going to read through, okay? And we're not going to solve these problems just yet. We're actually going to solve them later in the note packet. All we're doing in example 5 is determining whether each situation is a compound interest problem or a future value of an annuity problem, okay? So let's go ahead and read the directions. Example 5, read each problem and decide whether it should be solved using the compound interest formula or the future value of an annuity formula, okay? Not solving for anything, just trying to figure out which formula would I use to work the problem out, okay? So what I'm going to do is I want you to read through all 11 problems very thoroughly and try to decide what type of problem it is based on what we've already talked about in examples 1 through 4, okay? Do that, okay? And then come back to the video and I will go through each one by one and talk about which is the correct choice, okay? Now, before I let you go to do this, okay, I want to point out something that's very important, okay? I am going to go through each one of these problems really quickly, and I want to point something out to you, okay? So if I look at part A, okay, I see the phrase compounded daily, okay? If I look at part B, I see compounded quarterly. If I look at part C, I see compounded semi-annually. If I keep going through all of these, okay, compounded weekly, okay? I'm not even reading the problems. I'm just finding this phrase. Let's see, part E, compounded semi-annually. Part F, compounded annually. Part G, compounded daily. Keep going, okay? Part H, compounded monthly. Part I, compounded weekly. Part J, compounded quarterly. Keep going. Part K, where is it? Compounded monthly, and I think that's the last one. Okay, so if you read through all 11, they are all going to have that phrase compounded something, okay, whether it's daily, monthly, annually, whatever, okay? Do not automatically think because you see the word compounded that it's a compound interest problem, okay? Remember what I told you when we talked about when I introduced you to the formula sheet, okay? All the situations, with the exception of simple interest, will contain this phrase, okay? Compounded whatever, okay? So don't assume that seeing the word compounded automatically qualifies it for compound interest. That's not how you do it, okay? So for every single problem in chapter 3, you're going to see this phrase that I have underlined in blue, okay, unless it's a simple interest problem, okay? So in making the determination for example 5, okay, you do not make your decision based on this phrase because they all have that phrase, okay? You need to realize, what we talk, you need to try to implement what we talked about, okay? How do you decide between compound interest and future value of an annuity? Well, you're going to be saving money, and the way you tell the difference is by how often you're making a deposit. If it's compound interest, you're depositing one lump sum, okay? You put the money in the bank, okay? You forget about it. And then you come back after so much time and you see how much money is in your account, how much interest you've accrued, okay? If it is the future value of an annuity formula, okay, that means you're going to be saving money through regular deposits. So you may see something like I'm depositing, the $1,500 every single quarter, okay? So your money grows not only through the regular deposits, but also the interest, okay? So that is how you're supposed to make your determination. It's based on how often you're making a deposit. So keep that in mind that the phrase compounded whatever has nothing to do with your decision, okay? All right, so I'm going to give you time to go ahead and read through all 11 situations, okay? So pause the video, and then when you're ready, come back, and we'll go through them so that you can check your answers. All right, so hopefully you've gone through all the 11 situations, okay? We're going to start discussing which formula is the correct option, okay, for each problem. Okay, so let's take a look at part A. It says, if each day your fairy godmother put $1 into a savings account at 8.37% compounded daily, how much would the account be worth when you are 65 years old? Okay. All right. Again, this is a savings account. We see the phrase compounded daily. Okay. Compounded daily should not affect your decision. Okay. Because you would see that phrase in both a compound interest problem and a future value of an annuity problem. Okay. The key to figuring out the answer here is how often the deposits are made, okay? So what you're seeing is that the fairy godmother put $1 into the savings account each day, okay? So these are regular deposits, okay? That's what's going on here, okay? It's not a one-time deposit of $1, it's a dollar deposit every single day, okay? So in that case, because your fairy godmother is saving money through regular deposits, you would use the future value of an annuity formula. Okay? All right, so the second problem, okay, part B. How much should Tom set aside now at 7.9% compounded quarterly in order to purchase a $33,000 motorboat in 5 years? Okay, so what's happening here is Tom is saving money for this $33,000 motorboat. Okay, he wants to save the money in 5 years. Okay, and the way you read this, how much should Tom set aside now? Okay, so the way it's implied is that Tom is setting aside this lump sum of money and he's going to let it grow over a 5-year period and earn interest. And he hopes to come back in 5 years and have $33,000 accumulated. Okay, so this whole idea of setting aside the money now, that's a lump sum. Okay, so he's saving the money through one lump sum. So this is a compound interest problem. Okay, all right, part C. A person with $14,000 is trying to decide whether to purchase a car now or to invest the money at 6.5% compounded semi-annually and then buy a more expensive car. How much will be available for the purchase of a car at the end of 3 years? Okay. All right. So we've got our person who has $14,000. And this, you might find yourself in a similar type of situation where you have a sum of money and you're trying to figure out whether you should buy your car now with that money or invest the money for a little bit of time and try to grow it so that you can purchase a more expensive car a little later. Okay. All right. So you've got your person with $14,000. If they went the route of investing the money and then buying a little bit more expensive car later, they would save that $14,000 for the next 3 years and let it earn interest at 6.5%. And at the end of 3 years, of course, they'd have a little bit more money so that they could buy a slightly more expensive car. And so the deal here is this is the amount of money that would be invested. So this is the amount invested as one lump sum. Okay, so that's what's going on here. Okay, so since the person, I mean, the person, the interest is compounded semi-annually. Okay, you don't have a person investing $14,000 every 6 months. Okay, that's not what's going on here. Okay, they're taking that 14 grand and they're putting it in the bank, investing it, trying to grow it a little bit more to get a slightly more expensive car. So since it's a one lump sum, this is a compound interest problem. Okay. Part D. Find the total amount due on a loan of $17,500 at 8.5% for 6 years, 9 months. If the interest is compounded weekly, how much of this is interest? Okay. Here's a situation where we're not saving money. This is a loan problem. We have discussed in some of the earlier videos that you can talk about loans and investments interchangeably. They work the same way. So when you think about this loan that we're reading about in part D, the person is borrowing $17,500. They're borrowing this one lump sum. And so, of course, when it comes time to pay back the loan, they have to pay back the $17,500 plus the interest that is accrued over the 6-year, 9-month period. Okay, so it boils down to borrowing a one lump sum of money. Okay, so that makes this a compound interest problem. Okay, so moving on to example D at the top of the next page. Okay, Tim and Jessica have set up a Texas 529 plan in order to have $120,000 in 15 years for their children's college education. How much should be paid semi-annually into an account paying 6.8% compounded semi-annually to reach their goal? Okay, this is actually a real thing. Parents in Texas at least have the option of setting up a Texas 529 plan in order to save for their children's college education. So Tim and Jessica, their goal is to have $120,000 in 15 years. And so the way, if you read carefully here, obviously their money's going to earn interest at 6.8%, compounded semi-annually. But again, the key is how often are they depositing money in order to save up for this $120,000? And the key phrase is right here. How much should be paid semi-annually into the account? Okay, so what happens here is they're making deposits remember, semi-annually means twice a year. So they're making deposits every 6 months. Okay, so since there are regular deposits here into the account, that makes this a future value of an annuity problem. Okay. All right. Next. In a suburb, housing costs have been increasing at 5.2% per year, compounded annually for the past 8 years. A house worth $260,000 now would have had what value 8 years ago? Okay. Again, a little bit of a different twist here. This is not a loan. This is not a saving money problem. This is a situation that actually we see every day in the real world. Okay, happens over a period of time. This is something called inflation. Okay, a good example of inflation is gasoline. Okay, years ago, like say, I don't know, maybe think about like 1950 or something. Okay, was the cost of a gallon of gas the same price it is today? No way. Okay, it was much, much cheaper. But over time, okay, the value or the price of some quantity has increased. Okay, so you have the same product, just the price has increased over time. Okay, life changes. Okay, a gallon of gas is not the same price it used to be. Okay, like a house, that's what's going on here. You've got this suburb where housing prices have been going up over time. Okay, so 8 years ago, the house was not worth as much as it is today. It says right now the house is worth $260,000. Okay, 8 years ago it wasn't worth as much because over the past 8 years the housing prices have been going up. Okay, so how do you think about this problem? Okay, well, think about the value of the house. Okay, so 8 years ago, it had a lesser value than $260,000. Okay, that house 8 years ago, it was worth some one lump sum. Okay, that was less than $260,000. Okay, whatever it was worth, it has grown. Its price has increased at a 5.2% rate. Okay, and its value has grown to now be $260,000 currently in present time. Okay, so this is a compound interest problem, okay, because there's nothing about a regular deposits. Okay, think of the original price of that house 8 years ago as one lump sum that has grown to be $260,000 now in the present time. Okay, so anytime, the moral of this problem, part F, anytime you have an inflation problem where the price of something is growing over time to be a higher value, inflation problems are going to work through compound interest, okay? So I'm actually going to take a second here. I'm going to go to the formula sheet, okay? And I'm going to make a note on here that compound interest you can also use for inflation problems, okay? All right, so hopefully that makes sense to you. And like I said, we will work through this problem a little later, okay? All right, part G. How long will it take money to triple if it is invested at 5% compounded daily? Okay, again, we're back to saving money, okay? The strange thing about part G is there's actually no dollar amounts involved, okay? And you will see when we work this problem out that it actually doesn't matter. You can still do this problem even though you don't have a monetary value attached to the problem, okay? It's just saying however much money you want to invest, how long is it going to take that money to triple, okay, to multiply it in value by 3, okay? So basically, when you think about this, it's implied from reading this problem that you're investing this one lump sum, okay? And then how long will it take that one lump sum to triple in value, okay? So since this is a one lump sum that's implied, this is going to be compound interest, okay? All right, next, part H. You and your new spouse each bring home $1,500 each month after taxes and other payroll deductions. By living frugally, you intend to live on just one paycheck and save the other in a bond fund yielding 7.86% compounded monthly. How long will it take to have enough for a 20% down payment on a $165,000 condo in the city? Okay. Again, you're saving money. Okay. You and your spouse are saving for a down payment on a condo in the city. Okay. So what you do is you both bring home $1,500 each month. Okay. You live on one paycheck and you save the other. Okay. And so when you're saving the other one, that's how you're building your nest egg for this down payment. Okay. So what you need to realize again, how are you saving the money? Okay. Are you saving just one lump sum of $1,500? Or are you making regular deposits of $1,500? Well, what are you doing? You're basically, it says saving the other paycheck. So you're saving $1,500 each month. Okay, so again, you're bringing home a total of $3,000 between the two of you, but one of the paychecks is saved and one of the paychecks is how you live. Okay, so to save up for your house, okay, for your down payment, you are saving $1,500 each month. So these are regular deposits into your savings account. And so the regular deposits makes this a future value of an annuity problem. Okay. All right, 3 more, I think. Okay, part I. What is the final balance of a retirement account earning 5% interest compounded weekly if $40 is deposited at the end of every week for 35 years? How much of this final balance is interest? Okay. All right. So when you get a job, you start saving for retirement. Okay. So what's going on in this situation, in the retirement account, you are putting in $40 at the end of every week. Okay. So that's how you're making your deposits into your retirement account. You're making deposits at the end of every week. Okay. So we're saving money through regular deposits. Yeah. And so that makes this future value of an annuity. Okay. All right. Part J. A married couple has $15,000 towards the purchase of a house. For the house that the couple wants to buy, a down payment of $20,000 is required. How long will the money have to be invested at 7% compounded quarterly to grow to $20,000? Okay. Well, we just saw a problem about a down payment on a house back in part H. Okay. So in part H, to save for your down payment, you were saving $1,500 every month to come up with your down payment. Okay. J is a little bit different. Okay. It says that the married couple has $15,000 accumulated already, and then they need to save up $20,000. So they have $5,000 more to accumulate. So what they're going to do is take this $15,000 and invest it. So save it at 7% interest compounded quarterly. Okay. So to save for the $20,000, they're making this one lump deposit into their savings account of $15,000 and then kind of forgetting about the $15,000 until it grows through the interest to be $20,000. Okay. So this is a one lump sum. And so that means this is going to be a compound interest problem. Okay. Last one, example K. It says, suppose you want to buy a new car and you decide to save up for the car instead of taking out a loan. Okay. What amount should you deposit at the end of each month for 3 years in a savings account earning 4.5% interest compounded monthly to accumulate the $18,000 needed to buy the new car? Okay. All right, so you're trying to save for a new car instead of taking out a loan. Okay, so to save for your car, you're going to deposit some amount of money at the end of each month. Okay, for 3 years. Okay, and then through the deposits and the interest, you hope to accumulate $18,000 to buy the car. Okay, so the key here, you're saving money and you're saving money at the end of every month. Okay, so these are regular deposits. Okay, so since you're saving money through regular deposits, that means this is the future value of an annuity formula. Okay, all right, so that's all 11 situations. We have decided which formula we should use to solve each one. Okay, so in a couple more videos, we will start going through these exact problems that we've had in example 5, and we will actually solve the problem using the formula that we decided we need to use. Okay, so stay tuned.